Hello, everyone. So we have another AMC 10 problem. So this was number 17 from 2022. So the question says, how many three-digit positive integer ABC? So we are given digit ABC, satisfy this equation. So, and then there's a explanation in the parentheses. The bar in the top is that's telling us that's repeating decimal. So like this is one of the common types, which is why I just want to make another video about this one as well, because this is kind of interesting with the repeating decimal. So first things first, like when you have a bunch of repeating digit after the decimal point or even before decimal point, we have some general result. But if you kind of don't know that, so maybe you can take a look at some of the other videos I share about the repeating decimal. So, but this is the something I'm gonna just dive into immediately. So that this guy, when you have three digit are repeating, so this is equal to that three-digit number, so ABC, divided by 999. So the reasoning is just you just write this like number 0 ABC, 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 and then you just multiply by 1,000, so you can align those repeating parts and then subtract those. That's actually how we get 999 in the first place, but I'm not gonna dive into that much yet. Okay, so like the next one is basically 1/3. And then we have 0.8, which is going to be equal to A over 9. And then 0.B, repeating, is going to be B over 9. And then C over 9. So when you have this, we kind of find with this one compared to this one, but still, this is another good equation since we have a lot of fractions going on. But the good news is like we have all the denominators are multiple of 9. And this is actually a multiple of 9 when we multiply 9 like by 111. So you got this number. But 111 is also divisible by 3, which means I can multiply entire equation by 999. So that will give us ABC. And then if I multiply 1 over 3 by A over 9 by 999, so 3 and 9 will cancel, which is just 27. Or you can just say 111 divided by 3, which is 37. So which means we are going to end up getting 37 times those ABCs. So that should be 37A plus 37B and 37C. So, but be aware this is ABC, which is a three-digit number, not just product of ABC, just the three-digit number. So when you write this guy in terms of its digit, we actually get something better because the right side is given that way. So this can be written as 100A plus 10B and C. This is equal to 37A plus 37C. Maybe we should go with B first, and 37C. So this is fine, and let's simplify a bit. So if I subtract 37A from both sides, so you get, so 63A, and then 10B and 37B, so I can subtract 10B from both sides, so you got 27B, and then subtract 1C from both sides, so you got 36C. It's nice because we have the coefficient, they're all multiple of 9, so we just divide by 9, so that should be 7A equals 3B plus 4C. So now we have like the equation, but this has a 3 variable, and what we want is the number of like triples that satisfy the equation or this equation, because this is the same as this given guy. We just simplify to get this one. But we can try some plug-in numbers, but immediately, you know, when you look at the coefficient 3 and 4, that's add up to 7, which is the same as this one when you add those. So if I choose B, C, and A1, this will be 7, this will be 7. So 1, 1, 1 actually does work. So 1, 1, 1 is one pair. But this is not actually special because I can plug 2, 2, 2. That will be 2 times 3, that will be 4 times 2, which is going to be 7 times 2. This is 7 times 2, which means any pairs, I will say triples, that is the same numbers, that should work. So all of these, all the way to the 999, does work, which means we have at least 9 over there. So which is good because, you know, we don't have many options anyway. So you can go with this at this point, but we have to be careful because we might have some other ones as well, okay? So the first thing is like realizing those, like some of the coefficient was equal to this one, but at the same time, as long as you can keep the equation same, right? Both sides are equal to each other by changing those ABCs, you still have another triples that's possible. So like, but before we kind of dive into that way, you just need to understand how this is going to be related. So like if you change B by 1, which means if you increase B by 1, you actually increase the right side by 3 because you just multiply 3 by that change. And then if you change C by 1, you actually increase the right side by 1 or decrease by, increase the right side by 4 or decrease the right side by 4. So if you want to keep the equation same, while you are changing this term by 4, I can change this term by 4 as well, or the other way around. But the least common multiple is like 3 and 4 is 12. So which is why if I change the B by like 4, then I should change C by 3 so I can keep that, like kind of balance that. So I hope that's kind of clear. So what I'm saying is, but if you somehow take one of these triples and change those numbers 3 by 4, you actually get another one. But you really cannot like subtract 3 or add 3 if you are really close to ones or nines, because if you subtract 1 like 3 from the ones, you get negative, which doesn't work. So which means the number, like the pairs I need to look for should be at least 4, 4, and 4. So just imagine this. So this is A, this is B, and this is C. So like without changing A, I want to change B and C. So if I subtract like 3 from 4, so you will end up getting 1, and A is 4. But since I subtract 3, so then I should add actually I should do 4 because B has a coefficient of 3. So I should subtract 4. But if I subtract 4, it doesn't work because that will be 0. So which is why I cannot do that. So what I can do instead, add 4 to 4, that's going to be 8. If I add 4 to 4, I should subtract 3 from this 4, so which will be 1. So which means this is just another triple, does work. So if you are not satisfied, you can just plug into this equation. So the reason why that should work is like what we did was we subtract like 4 from B. Add 4, like add 4 to B, because if I increase B by 4, this guy will increase by 12, and then I need to keep that by subtracting 3 from C, so I can subtract 12 from the right side so you can keep the equation. So this is one thing we can do, but I cannot do the other way around, which means I cannot like subtract 4 from 4 and add 3 to this guy, because that will be 0 and 7, but it doesn't work because 0 is not what we are interested. We are looking for the positive integers. So this is the only one we can make with using this pair. So which means we have one more already. So similarly, I can just say like 5, 5, 5. So if this is my next triple, then I will change the numbers. So I'm going to keep the 5 as 5 for A. So B and C should change. So B should decrease or increase by 4. So if I decrease by 4, so you will end up getting 1. That means I should increase this by 3, which has to be 8. So that should be 1, 8. 5, 1, 8 is another triple. So if I keep the 5, increase this by like 4, so you should get 9. Decrease this by 3, so you get 2. So that means this is another triple. So 5, 9, 2. So far we end up getting 1, 2, 3 more. We had 9 already. So 9 plus 3 is 12. So that means these are not correct either. But if I look at this 6, 6, 6, which will give us one more triple as well, because 6 and 4 are kind of symmetric. So I cannot add 4 to this guy. That will make 10, but I can subtract 4. So that should be 3. And then I can increase this by 3. So that should be 9. So 6, 3, 9. Let me double check. Actually, I should subtract 4 from this guy. So that should be 2, not 3. So that should be subtract 4. So that's 2, add 3, that's 9. So 6, 2, 9 is another triple. So far we have 4 additional other than our first initial 9 triples. So that's going to be 13. So we have 14 as an option, but be careful. But if you try some other ways, you really cannot. but we kind of use all the available ones, so which has to be choice D. So that was interesting problem. So it's a bit number sense and just kind of using our knowledge about the repeating decimals. So I hope that was clear, and I'll see you in the next video.